All right. Hello, everyone, and good morning slash afternoon, depending on where you are joining us from. Welcome to today's Cosmic Conversations. My name is Mary, and today I'm here with Logan Kennedy from the Human Landing Systems, or who is a Human Landing Systems engineer from the Marshall Space Flight Center. And how are you doing today, Logan?
I'm doing great.
Awesome. So you're here to talk to us about something very exciting. I'm sure people are looking forward to the Artemis mission, which is all about sending humans back to the moon.
Right.
And I'm going to pop back up near the end of the presentation, and I'll be looking out for questions. So if anybody watching has questions at any point throughout the presentation, please put those in the comment box, and we will address them at the end. But I'm going to bring up your presentation, and I'm going to disappear and let you do your thing.
All right. Appreciate that. So like you said, I'm Logan Kennedy. I work on the Human Landing System, which is a part of NASA's Artemis program. My role is I am the Surface Mission Segment Lead. So we have divided the mission up into segments, into phases. And so I'm responsible for everything that happens on the surface, which of course I'm not biased, and that's the most important part. That's where we're doing the EVAs and everything outside the vehicle. Next slide. So talk about Artemis overall is what I'm here for today. Human Landing System, HLS, is just one part of it, and it's an enormous effort by NASA. Of course, we got to talk about the name to start. Artemis is the twin sister of Apollo. We're all aware of Apollo happening back in the 60s and 70s, and it's a great name. I've got 2 young daughters myself, so Artemis is awesome. We plan to go back to the moon by 2024, and we're going to the South Pole of the moon, which you've never done before. And there's a number of challenges and advantages of going there, which I'll talk about later. And we always want to keep our sights on the next goal, which is going to Mars after that. And we're going to use moon as a stepping stone to go to Mars. So the first part of the Artemis program is the launch vehicle, the SLS, the Space Launch System. It is an enormous rocket. And it is going to carry the humans in the Orion capsule into space and get Orion to where it needs to go. It's going to be the backbone of our mission. It's an enormous vehicle. So there's the Statue of Liberty and the space shuttle. If you look really, really closely, you can see a person and a giraffe down on the bottom there. The Saturn V for the Apollo program is there on the right, which is 360 feet tall. SLS has a couple different variants that we are building and planning. The one in the middle there is Block 1. That's the one for the very first mission, and it only gets bigger and more capable from there. So the one right next to it is Block 1B, Block 2, that has a much larger upper stage that can do more and go farther. So the main point of SLS, the launch vehicle, is to launch the Orion spacecraft. So it's the crew capsule where the crew lives for a long duration in deep space. You can think of it compared to the Apollo spacecraft, the Apollo capsule, the command and service module. Same idea, except bigger, more capable, more people. So it's 4 people instead of 3. You can see it has solar panels there on the side. The Apollo crew module had fuel cells, which were limited. Once you ran out of hydrogen and oxygen to power those, you were out of power. But with solar panels here, you have power as long as you can see the sun. Of course, there's other limitations like food and things, but it's a much more capable vehicle, much bigger, and much more comfortable to live in. So this is, it's hard to overstate how amazing this picture is. We've seen artist renderings and animations of these missions, these vehicles for so long, but this is the actual Orion capsule at the Kennedy Space Center where it'll be launched on the Artemis 1 mission. So we're talking real hardware here. This isn't, these aren't, animations or plans for years and years down the road. This is happening very, very soon right now. And that's the actual capsule there, which is so fascinating. There's a lot of work that also goes into launching, and there's so many little pieces to it. The mobile launcher, of course, is important. How do you get that giant rocket from its assembly in the VAB, the Vehicle Assembly Building, out to the launch pad? It's a feat unto itself, and they've already tested out that vehicle and rolling it out to the launch pad. And then at the end of the mission, of course, we're splashing down in the sea. The water is a pretty easy target to hit. There's some big oceans on this planet, and we with the shuttle, the shuttle returned and landed on a runway. But the spacecraft here, just like Apollo, is going to return at sea. So we're preparing for that recovery. So all that work is going on in parallel as we're getting ready for these first few missions. So this is what I'm here to talk about, the Human Landing System, HLS. This is what takes the crew from the Orion vehicle in lunar orbit down to the surface. It's what they live and work out of while they're on the surface. and then they come back up and rendezvous back with Orion on the way there. That image there is of what we call the government reference design. And so we last year, we spent a lot of time working on exactly what we want this mission to look like and what the requirements need to do, what the vehicle needs to do. And we didn't have contracts ready yet when we were working on it. And so we had to come up with an idea of what we thought the vehicle would look like and what it would be capable of. And that was our vehicle that we worked on. You'll see a lot of images that use that vehicle. But you may know that we have awarded the contract for these first 3 companies to do this mission. So these are so interesting, just comparing them side to side. They're all so different, and that's such a good thing. We call it dissimilar redundancy. So all 3 missions are going to accomplish the same mission, but they'll do it in very different ways, and that's a very good thing, because if they all relied on the same technology, the same tanks, the same method of doing things, and one ran into a problem somewhere, they would all be in trouble. But they do things so differently that it's fascinating. So with Dynetics, that's a company on the left here. They're based out of Huntsville, Alabama, where I live. And they have this low-slung crew cabin concept where the capsule where the crew live is close to the ground. SpaceX in the middle is using their Starship. You can see it's a very tall vehicle. If you look closely, you can see crew riding on an elevator down to the surface. That's how they perform their EVAs. And then on the right there is the Blue Federation, Blue Origin consortium. They have a ascent element, descent element concept. You can see a crew member standing next to it there. So they're all 3 different designs and very, very different. It's really interesting to see how they all took the problem and how they solved it. So we talked about going to the South Pole. Why do we want to go there, and what are the challenges and the advantages of going there? Well, first thing, we talked about Shackleton Crater. That's centered right over the pole, and it's a good example of where we might go, somewhere around Shackleton for this mission. And it's real big. The crater is about the size of Washington, D.C. We think about the moon as being kind of small, kind of far away, but it's a very, very large surface that we're going to. And the South Pole is tricky. And if you show on the next slide here, one of the reasons why it's so tricky is that if you think about people that live up in Antarctica or Alaska, the sun does weird things on the poles of these planets and moons. If you're on the equator of Earth or on the moon, you have a regular day-night cycle. But on the moon, the day is 14 Earth days long, and then the night is 14 Earth days long on the equator. But on the pole, just like on the poles here, it goes around your head. And you think about people in Alaska, the sun's rises in May and sets in August. And there's some very strange things that the sun does. And that's very, very good, because the sun is really good to have a lander and a moon base. If you want to have sun for a long period of time, and if you're living on the surface for a month or longer, you want as much sunlight as you can for power, and because it keeps you warm. The shadows and darkness in space are very cold. But the darkness that you can see in certain areas is also really interesting, because we call those permanently shadowed regions. We have a pretty good idea that there's water in those permanently shadowed regions. And what we want to go find out is how much water and how deep is it, and what kind of compounds is it tied up in, and how well we can use it. So we go there, we can go to a place where we think there's going to be sun for a long period of time, and we know we'll be close to permanently shadowed regions where we think the really interesting water and science is. So that's why the poles are really interesting to us. So what will we do on the moon? Touched on a little bit. There's a cool picture of a crew getting off the spacecraft there. We have a couple of rover concepts there. The one on the left is a crew-driven rover, similar to what we had on Apollo. And then in the background there, you see a robotic rover. That's an example of something called Viper, a robotic mission that's going to the moon in 2023. And that mission is going to go learn more about the water that we're going to go find out. It'll get there before the first ageless mission, and it will help inform where we go and what we do when we get there. Next slide. So the biggest thing we're going to do on the surface, and the biggest piece of my mission, of my part of the mission, is the XEVA system. And you can think about it as a spacesuit, but it's a lot more than that. It's the tools that we're going to use, and the vehicle interfaces. So how we get the suit on and off, and how we recharge the suit. The suit is called XEVA because X for exploration. We use spacesuits up on the ISS right now, the EMU, and it is a great suit. It's been used for decades now. And this suit is based off that design, but it improves upon it in a number of ways. One of the biggest ones being mobility. You are able to get around a lot better in this suit than the current one on ISS, and especially Apollo. On Apollo, the suit that they had was great, but there's you may have seen, and there's images in another presentation about them falling over all the time. And you just couldn't walk around very easily in these things. And I like to think of a spacesuit as a small spacecraft into itself. It's fully capable life support on the backpack there. And you're kind of walking around inside of a stiff balloon. It's not an easy thing to work in. And this suit makes a number of changes, a number of advantages to make mobility a lot easier on the moon, because you're going to be bending down and you're going to be using tools to get rock samples and everything that you see in this picture. So there's a lot that we're going to be doing. This suit is going to be tested on ISS in 2023 as a replacement for the current spacesuit that's up there. We're going to build it in-house for the first mission. And then after that, just like how we're relying on commercial industry for the landers, after that, the spacesuit will be built by U.S. industry for beyond that. So this slide was made by a scientist. I do not claim to be a scientist, but I can try to speak to it as best I can. So the moon is not a cold, dead rock. It's got a lot of interesting things going on. If you are a planetary scientist, we can learn so much from anything for how old planetary processes to what the ancient sun looked like. Of course, the interesting thing to me as a human lander type person is what the volatile cycles are, the water cycles, and like the image of the water that's kind of under the surface there, and then how deep it is and where it is. We'll be using a whole lot of science, both on the rock samples we bring back and on the experiments we do there to learn about the moon. There's an example of using field geology and the rovers we would use over there. Science instrumentation, like I said, the Apollo missions deployed some really valuable science experiments that some of which we still use today, and we hope to keep on that thread for these future missions. So Gateway is another big part of the Artemis program. So we talked about Orion in that top right quadrant, the government reference design for the human landing systems, the bottom right, and then the rest of it is what Gateway brings. And so Gateway is kind of a mini space station around the moon, but it's a lot more than what you think of the space station today. It has a pretty significant propulsive capability. So that bottom left portion has propulsion on it, and the Gateway can change its orbit, change where it is to adapt to the mission. It's in an orbit that allows a lot of advantages for communication and preparing for the mission as we go down to the surface. And this is just the phase 1 of the Gateway. Phase 2 and beyond adds much larger habitats and much longer duration stays and more science that we can do out of it. So it starts out helpful, and it gets even more helpful as we go along. So with keeping our focus on Mars, why is the moon the next step? What's important about the moon? And it's pretty easy to see there, 3 hours, 3 days, and 9 months. Those are very big differences. We have a lot of experience in low Earth orbit with ISS. We've been living on the space station for decades now, or a decade. And you're only 3 hours away. If something goes wrong, you can get back pretty quickly. And we use that orbiting platform to learn how to live in space for long durations of time, and we've done it, and we've learned a lot. The moon's about 3 days away, so it's not too terrible. And learning how to live on a planet, on the surface of a different planet, is a lot different than learning in space. Just being in the presence of a gravity field and how your bathroom works is something we'll need to learn, because going to Mars is 9 months away at best. That's if everything's lined up. At worst, it can be a lot farther away than that. And while we eventually want to go there, because it's probably one of the most interesting planets we can go to, at least one of the closest ones. There's some interesting moons out by Saturn and Uranus and Jupiter. But it takes a really long time to get back. And we need to really have a good handle on what it takes to keep people alive on a lunar surface, on a planetary surface, and know how to be safe about it. And so that was the moon was being used for. So I'm sure everyone got up early yesterday to watch the launch of Perseverance, especially early for everyone out in the Pacific time zone. So we've been to Mars a bunch robotically, starting with that little Sojourner rover way on the left there. It's interesting to note that these are not to scale. Sojourner was tiny, and Curiosity and Perseverance rovers are the size of small SUVs. They're huge. But the goal is to eventually put humans there, and going early robotically is so helpful, because we learn what the planet is like, what the atmosphere is like, what the planet is doing, what its weather is like. It does have weather. It doesn't have a lot of atmosphere, but there's a lot going on. If you've seen the movie The Martian, you get an idea of how difficult it is to live there, and the difficult things that he had to do to stay alive, which were, pretty well based in science. Great movie, great book. But it's, like I said before, it's going to be challenging to go there straight from our experience with low Earth orbit, and so we'll use the moon to learn more about that. This is a cool picture. This is what it would look like to be on Mars and looking at Earth, and you can just barely see the dot. That is Earth. It's really far away. Yep, right up there. The sunrises and sunsets on Mars are going to be a whole different world, and we eventually want to have humanity spread across the solar system, across the galaxy if we can, and Mars is really the next big step for that. So we're getting ready to do that. So the last couple of slides, I think, are some of the most important. I am, of course, an engineer that works at NASA, and that's maybe what you think about when you think about NASA. But NASA is very diverse, and you don't have to be an engineer. You don't have to like math to work here. I started out as an intern, so you start in that top left there. I highly encourage anyone who's a student or will be a student to do an internship or a co-op, which is what I did. I started working at NASA when I was 19 years old and was sworn in as a government employee. It was very strange. I didn't know what I was doing. And I gained valuable experience in those 2 or 3 years before I graduated. Not only did I do better at my classes in college, but I had a ton of experience working for NASA. And then NASA hired me as a full-time employee after that. So I highly encourage anyone to use an internship to get a leg in the door. Of course, flight controllers, if you watched the launch yesterday, you would have seen a lot of flight controllers. Those are the people that run the missions, the many missions that NASA has at any one time. It's really an amazing number of missions that you have if you think about it. Of course, technicians, they get down and do the dirty work. They build things, they weld things. The engineers kind of have a goal of what we want to do, and then a technician executes it. And they're obviously very important. Launchpad construction is an example of something like that. And then for astronauts, for working on the human side, there's a lot that goes into training and preparing astronauts for their missions. The space station missions, we've done a lot of the EVAs and the repair work we've done up there for a while. And so we're getting pretty good at it. But this mission back to the moon is going to be something completely different. And there's a lot of work that goes into training the astronauts for that. And then, of course, not even close to anything else, but social media and graphic artists. Okay, I didn't make this PowerPoint slide. Someone who knows a lot better how to make pretty things made this, and I'm using it. But social media is so important. Reaching out to the public is immensely important, which is why I love taking time out of my day to do it. It's important to inspire the public and be a good user of taxpayer money and tell people what we're doing and get them excited. I know there were millions of people watching the Perseverance launch. I don't have to tell you too much to get you excited because space is so interesting. But that's a big part of what we do here. Of course, there's a picture of Curiosity down there. So robotics is a big part. We have so many robotic missions. The human side is just one of many. And then geologists and food scientists. We got to know what kind of rocks we're going to dig up when we get there. If you sent me to the moon, I would have no idea what I'm doing. The geologists are the ones that know what rocks are interesting, what we can learn from them. So I work a lot with the lunar scientists to determine what we're going to do on the surface. And then, of course, near and dear to me are spacesuit designers, since I work with the EVA community and what we're doing with the spacesuit and how it's different than the other ones we've done. So many jobs, so many experiences, so many options. If you want to work for NASA, with NASA, it's a great place to work. So the time is now. Let's go. All right.
Awesome. Thank you so much, Logan. That was super interesting. We definitely had several questions coming through. Let's see. Let's start from what you were just talking about and go backwards. So one thing I was wondering, I didn't catch if you said this, roughly how many people does it take? Because you're talking about all these different types of jobs that you would need. Roughly, what does that add up to? How many people are working on these missions?
So I think that the number I heard not too long ago was just for HLS, just for the lander part. This doesn't account SLS, Orion, Gateway. People they're not all full-time, but they're all people that are all paying attention. It's over 1,000 people.
Wow.
So just the EVA community that I work really closely with is 200 people just alone. I mean, those spacesuits are entire spacecraft, and they're so complex, and it is rocket science, right? So it takes a lot of people to have the expertise across all the different pieces of the mission.
Oh, that's amazing. And we did get a thank you for showing us all the different jobs as well. Let's see. There was a question about the landing system designs, are all three of the contracted landing system designs going to be used, or just one?
Sure. So we're in the first phase of that contract. It's 10 months long, and at the end of that first phase, there will be a down select. It could be one or two. I don't know exactly right now, but the idea is that we'll have preferably 2 missions that go to the moon. Yeah, preferably 2 of them, and once again, dissimilar redundancy. If we could pick all 3, we would love to, but we want to have more than one because we plan to go more than once. And we may pick one to go in 2024, and then another one to go in 2025, and then maybe another one to go years after that. So we're unlike Apollo. So I get the comparison to Apollo a lot. I'm a big Apollo buff, by the way. They picked one lander off the bat, and it was good. It was a good idea, but they had to work with them a lot to make sure their vehicle was what we needed it to do, and it was a lot of work. Whereas if you have multiple and they're doing things so differently, we can kind of down select later and go with the ones that go hopefully too.
Interesting. So a lot more flexibility.
Mm-hmm.
That's cool. Ryan was wondering why Viking wasn't represented in the Mars mission. Is it just because it wasn't a rover? Poor Viking.
I suppose. Yeah, I know. I'm a big fan of Viking. I mean, there's so many. I mean, the orbiters are super important to Mars, right? So I would love to put the orbiters on there too. Yes, unfortunately, that was a rover-only, mobile-only slide. So, but please, I'm not a Viking hater at all.
The rovers do seem to be the most charismatic of the.
Right. Charisma is a big part of space.
Yeah. Let's see. Are there any substances on the moon that might be converted to water, food, oxygen for possible long-time human colonization?
Yes. So we know there is water. And like I said before, we're trying to figure out how deep it is and how distributed it is, how much there is. You can use that water to drink. You can use it to make rocket fuel. So it's made out of hydrogen, oxygen, which is rocket fuel. You can use it in fuel cells. Water is a really good radiation absorber. So I've seen concepts of habitats where the walls are filled with water and they help absorb radiation. So that's kind of the easy one is water. But there's a lot more that's going on the moon, and there's a lot of concepts of building habitats out of the regolith, out of the dirt, the moon dirt, because you want that radiation protection, right? Earth has the magnetic field around us that protects us, and the moon doesn't. And you have to find a way to be protected. You can live on the surface for weeks, maybe, but if it's going to be anything longer than that, months or years, you want some sort of protection. And so you can use the moon's resources that are already there to build the habitats. It's not food, though. I don't think you can make the dirt into food. That wouldn't be very good.
Can you do a similar thing on Mars as well? Is there a similar amount of resources, or is it different?
Yeah, it's different. It's the same in that there's water. We know there's water there on Mars. And the crazy thing is that in some cases, there's liquid water on Mars that's really salty. And we think that it's liquid water, but there's water on Mars as well. And that's probably the most important thing that you're going to get there. Neither one have very good atmosphere, right? The moon doesn't really have any atmosphere. Mars's atmosphere is 1%, ours is, and it's mostly carbon dioxide. So they're very similar in that sense. But yeah, on Mars, once again, there's not a lot of food you can get out of it. If you look at the Martian, you use some Martian soil to grow food, and that may be possible, but we'll have to bring a lot of that stuff with us, and we'll have to recycle a lot of it, right? So if you think about the space station, they recycle water and they recycle just about everything they can. And we have to learn to do even better than that if we're going to go to the moon and to Mars. So that's why the space station has been so critical these past couple of decades, is that we're learning how to live off what we bring.
Yeah, totally. And speaking of The Martian, book or movie, which is your favorite?
Book, of course.
I just recently started the book. I haven't finished it yet, but it is very good.
It was one of the few books that I could not put down. I read it in 24 hours, something like that. The movie has a wider audience, right? Okay, I will not downplay the audience that you can get with a really well done movie like that. But for the technical details and the way that they told that story, the book, I think it's behind me actually. I think it's somewhere over there. I don't know.
I think
there it is.
Yeah,
right
yeah.
That's the book.
Excellent. Let's see. Someone asked what materials the suits are made of and how do they stay airtight?
A lot of different materials. So just the spacesuit itself, once again, it's an entire spacecraft. It has 6 or 7 different layers just to keep the crew safe. The outer one is a micrometeoroid protection and a thermal layer. It gets really hot in the sun, really cold in the that was a cool animation. Hot in the sun, cold in the dark. And so it helps prevent the heat or the cold getting to the crew. And the very, very innermost layer is a liquid cooling garment that has water running through it that regulates the crew's temperature, because they are working their butts off on the surface, and we have to keep them cold. And then in between that, there's the pressure. There's the suits run at about 4 psi, which isn't a lot, but when you compare it to vacuum, it's a pretty tight suit, and so it's made out of the same kind of stuff that keeps air in anywhere else on a tire or anything like that. It's just really, really well designed and very safe. So it's made of a lot of different things, and it's a really complicated and interesting spacecraft.
Something I'm curious about looking at this video, where are the places that they're testing this outside?
Yeah, so there are a lot of places in the country and the world that are analogs to Mars and analogs to the moon. There are a lot of craters that we use. There's stuff out in Hawaii. There's a lot out in the Midwest, Arizona. There's a crater that has very similar dirt to it's a certain kind of volcanic ash that's very similar to the moon. And so you can study what it's like to get your spacesuit covered in dust, and you can see what it's like to kneel down. Now, of course, you're in 1G, and so the gravity is a little different. But yeah, there's places all over the place.
That's cool. Then one we had earlier, someone was wondering, what was something you learned while working HLS that you didn't know before?
Oh man, that's too many to list. My background is in robotic landers, so the human side of the house is brand new to me. And I mean, I'm trying to think of a good example. How do you go to the bathroom in space? Of course, everyone asks that question, but going to the bathroom on the space station versus when we're going on the moon is very, very different. How do you design a bathroom that can work both in 0G, micro G, and on the lunar surface, and be small and lightweight, because every pound matters going to the moon and back. So just anything having to interface with the crew, how their day works. They get a certain amount of sleep every day, and their meals are very tightly controlled, because if you give them, the food has to be designed in a very specific way. So anything that has to do with humans and how they live and work in space is brand new to me. It's been fascinating.
Interesting. Cool. And I know we just got a new one too. How many astronauts is Artemis intending to support on the moon or Gateway at any one time?
Sure, good question. Yeah. So the first missions are going to be 4 crew. We like to say the first woman and the next man. So that's awesome. Like I said, I have two daughters. For the first mission, 2 crew will stay on Orion, and 2 Orion or Gateway, and 2 will go down to the surface. But the eventual goal is to have all 4 crew go down to the surface. And the part of that, they call it a sustaining mission, is to have more than 4 crew, stay there for months at a time, to have habitats, to have pressurized rovers. When you have an unpressurized rover like Apollo did, and like what I showed, you're limited for the number of hours you're out there. You're limited by what the suit can do. But a rover, if it's pressurized, can be a small little habitat that you're living and working out of, and you can go a lot farther distances, and you can stay out for a lot longer if you have more than that. So initially 4, and 2 on the surface for the first mission, and then more and more later.
Will they ever plan to stay there for longer than months? Like, I know on the ISS, the longest anybody has stayed was not even quite a year. Do you know if there's any plans to have people live on the moon for longer than a few months at a time, or no?
I mean, my long-term goal is that people live on the moon permanently. People live on Mars permanently. People live anywhere permanently. So yes, that is the long-term goal. We have to get only one foot on my soapbox here. The planet is not going to support us forever. You're talking, maybe thousands or millions of years down the road, but it's also really hard to live on Mars and really hard to live on the moon. And to get it to the point where a sizable chunk of humanity is living off planet, we have to start now. So yes, there are plans for that. Having a moon base will be the eventual goal. People have been comparing it a lot to a base on Antarctica, and I forget the name, but that base was built up incrementally, slowly, with small crews, and it got bigger and bigger and bigger and bigger until it could support a lot of people for long periods of time. And that's the same idea. We'll start small as we learn things, and we hopefully will leave things there that can be used in the future, and eventually have a fully permanent presence on the moon.
Nice. And looks like we got one more. How long do you anticipate it'll take to build a long-term habitat on the surface?
Man, I wish I had a better answer to that because I'm so focused on this first mission, right? I don't know the details of that later mission. So the plans are, crewed missions to the moon every year or two, and after we get these first couple ones under our belt where we're learning how to do it, those later missions will start building the base. And will it ever be done? I don't know. You never want to be done with that, something like that. So I don't think that with the space station, we had this plan and we built it and then now it's done. With the moon base, you eventually want to get that thing supporting 100 people, more than that. So and Mars as well. And a big part of that is going to be working with commercial partners, all three that we have and more to help. One of the things that I think NASA has done such a good job of recently is incentivizing and allowing commercial companies to innovate and bring their own ideas and make them profitable. So an area that I didn't touch on is something called CLIPS, the Commercial Lunar Payload Services Program, which if you follow space, you may have heard of it. There's now 3 missions going to the moon that are smaller. They're robotic, they're not crewed, but they will be bringing science instruments and technology demonstration. And NASA just pays them to deliver these things. We don't own these missions. We just say, bring this box and give us the data when you're done with it. And we want them to be profitable. We want them to be successful. NASA is not their only customer. They're bringing people that are, sending their parents' ashes to the moon or wedding rings to the moon. We want them to be successful so that we can take advantage of them. So commercial industry and the way that they're going to do these missions are a big part of the plan, and I'm really excited about it. If you had told me a couple of years ago that there would be regular cargo deliveries to the moon starting in 2021, I wouldn't have believed you, but that's the case.
Yeah, it's pretty wild that it's happening so soon.
Yep.
Great. Cool. I'm not seeing any other comments coming through right now. So thank you so much for this, Logan. This is amazing. And I hope that you can tune in for our future cosmic conversations. I know we're still working on a few of them, lining up what they're going to be exactly, but hope to see you all again on a future Friday. And I hope you have a wonderful rest of your day.
You too. Thanks, everyone.